Hey everyone, welcome back to my channel. I hope you all are doing awesome. So imagine building a system where services work in isolation and they never talk to each other. So that system would fall apart instantly. But microservices are independent. They must collaborate to deliver a business value. But the real question is, how do microservices communicate? So let's explore this. So in this particular video, we'll talk about how do microservices communicate and what are the key practices that we have to keep in our mind while developing microservices. Okay. So without any further ado, let's start with the video. Let me quickly share my screen and see you there.
Hello, hello, hello. I hope my screen is visible and I am audible. So, okay. So before just starting with the video, let me tell you something or just a heads up. लाइक पिछली वीडियो में मुझे फीडबैक मिल रहा था कि जो ऑडियो क्वालिटी है वो अप टू लेवल नहीं है वीडियो की. तो I have tried something else this time. So drop a comment if you are just observing that this audio quality is better than the earlier one. So drop a comment. I'll try to make videos in using this mic, then otherwise we'll move back to the earlier one if that was better. Okay, so cool. So yes, the real question was, how do microservices communicate? So here you go on the screen. So it's like the microservices rely on your IPC. And what is IPC? IPC is your inter-process communication. Okay, so it's like your microservices are independent. They have their own dedicated database, services, and everything, and they rely on IPC, inter-process communication, and choosing the right. As you can see here, I hope my screen is visible. It's not coming. Yeah, now this is coming in the screen. Perfect. So microservices rely on IPC, and choosing the right IPC makes your application smoother, faster, and easier to maintain. As you can see here, your microservice. Where's my laser pointer? Yeah. Your microservices rely on your IPC, and IPC, choosing the right IPC makes your application smoother, faster, and easier to maintain. So the next we have, like inside microservices, we have two ways of communication, which is your synchronous and asynchronous. Let me show you here. So as you can see here, I hope my screen is visible with this. So as you can see here, we have two main ways of communication. One is your synchronous communication and another is your asynchronous non-blocking. Synchronous is blocked like immediate response based on whatever you have requested. Okay, so let's understand the asynchronous. Okay, so let's understand the synchronous communication with the help of analogy. Okay, so yeah, it's visible now. It's like बड़ी डिस्प्ले है तो कितना पोर्शन वो कवर कर पा रहे तो मुझे वो यहाँ से देख के तभी उसको फ्रेम में लाना पड़ रहा है. ओके. So the analogy is like a phone call. You ask and you wait for the answer. Like when you dial a number, make a phone call, you are waiting for someone to respond back until you are there, and you are not doing anything other than that. Okay. So that is your synchronous communication. Immediate response based on whatever you are requesting. So the example could be like you can use the HTTP or the gRPC. So, okay, so then what would be the analogy for asynchronous non-blocking? As you can see here, asynchronous non-blocking means like sending a WhatsApp message or the mail that receiver reads it later. Okay, so what is the advantage here? It's flexible, non-immediate. Like you have just fired the event, you have sent the request. Now you are not waiting for the response, or your main thread is not blocked here. You are just doing your rest of the work. Okay, and messaging protocols we use basically for your asynchronous, that is your Kafka, RabbitMQ, and all those. So this, so these are the two main ways of communication that we do in your microservices. So the next we have, yeah, okay. So next we have crucial design choices. So here we have interaction styles like one to one, one to many. Okay, in both synchronous and asynchronous. So just give me a sec. Okay, so for one-to-one synchronous, it's a standard request response. You are sending the request, you are getting the response is it's one to one. Like your one client is sending a request to the service and one service is responding. Like when you have one to one asynchronous, you fire and you forgot, or async response, like whenever there would be response, it will send back to you, but you are not immediately waiting for the response. One to many is asynchronous, like pub sub, where one event notifies multiple services. Yeah, you have just notified, or it's like you have published something from the producer, and there are multiple services or the receivers who are just consuming from that particular topic. Okay, so that was the interaction style. In the next, we have pick the right messaging format. So we have like different messaging formats. But before just starting or just defining like I want to go synchronous, asynchronous, or this would be my flow, pick the right messaging format. It's like keep it language neutral. Absolutely. Since today you might use Java, tomorrow go Python or Node.js or anything. It's like today you are using Java, but tomorrow you can go with the another language. But if you are just making that language specific, so it would be hard for you to evolve with the time or just change the language. So if you are just going with the language specific, then there will be an issue like when you have to move or switch your language to any other. Okay, so now we have two formats here. One is your text based, and the second, as you can see here, is your binary based. So inside the text, we have JSON and XML, which are human readable. And it's like most of the time we use this only because these are based on your HTTP. It's human readable, self-describing, and it's easy to debug and integrate. Okay, so this is your text-based and JSON XML. But then we have the binary based also, like where we have the Avro and protocol buffers. And these are basically your binary formats when we are sending across the network. These like formats, so nobody can read between them because it's a binary, and it's compact, efficient, and faster to serialize, deserialize. Absolutely. Now here, or it is ideal for your high performance systems. It's compact, efficient, and faster to serialize, deserialize. Yes, because it's a binary one. You can easily like what you have to do. These basically use your, as you can read here, these use your ideal interface definition language to define message structure, and the compiler generates the corresponding code as you are working in Java, C Sharp, or Node.js. That generates the code for your serialization and deserialization. That was for your like binary Avro in Protobuf. Cool. But there is a one quick tip: don't rely on language specific serialization like Java. एब्सोल्युटली लाइक अगर आप स्पेसिफिक डिपेंडेंट हो गए जावा के लिए और कल को अगर आपको लैंग्वेज चेंज करनी है देन यू कैन नॉट डू दैट बिकॉज यू आर जस्ट डिपेंडेंट ऑन जावा serialization. Then you have to change all of the things. Rather than you can just go with the binary based and just you have to compile that and it will give you the entire serialization deserialization code for that. And yeah, this was the tip. Now it's readable. Cool. What next we have? Yeah, now it's coming in the frame. Perfect. So next we have the synchronous patterns. So synchronous pattern, we all know it's like sending a request, getting a response. Our main thread is blocked. We are not doing other stuff. We are just waiting for the response here. So here we have the one we can use the REST based on HTTP. It's like there are few like I would say benefits and limitations of using the REST. It's your simple and familiar. It's like everybody knows. It's easy to integrate, and most of the time we use, and most of the developers are familiar with your REST, and easy to test, naturally fits request response. Yeah, we can easily test the your REST endpoints in your Postman API clients in your browser as well. So it's easy and no broker required. Like your client can directly communicate with the service. There is no intermediate broker required. But this is synchronous only. This was the limitation. Requires service discovery because client needs to know the URL of the each of the service and what is the port number and all those. For that it requires the service discovery and no message buffering. Yeah, there is no message buffers, like you are just making a call and getting the response. There is what else? Yeah, that was for your REST, and next we have your gRPC. Okay, for the gRPC, like it's high performance streaming support. Inside streaming, I would say it's a unary, like sending a request, getting a response. It's a client streaming. Client is sending the streams in a streams as a request and getting a response. Then server streaming, client send one request and you can get the streams as a response from the server. Then you bidirectional, both like client and server both can stream. So I already have one dedicated series on gRPC. If you haven't checked it out and wanna know more about that, so yeah. So this is the playlist I have already completed on my channel on the gRPC. If you don't know what is gRPC and just wanna start with the gRPC, so this is the beginner friendly complete playlist of gRPC. Here I'm using C sharp, but language doesn't matter. As you all know, you are developers, so you can just watch for the content and knowledge, not language specific. As we were discussing here, so don't go like the messaging format. Don't go with your language specific. Okay. So this was for your synchronous, and next we have asynchronous patterns. So what we have inside asynchronous, like we know we use your message brokers. So as you can see, we use message brokers like your Kafka and RabbitMQ. We send the request and we forward. We don't wait for the response. Just a sec, I'm getting call. I cannot take this call right away. Okay. So next we have like inside that message brokers, it's a Kafka and RabbitMQ. Like we send the request and we forward. We don't wait for the response. The particular services, it's like suppose we are working with e-commerce and you have just placed an order. You have sent your event to the topic or the message broker, and the corresponding services like your billing service, your delivery service, they are getting the notification. They are just consuming the data from that particular topic or the message broker, and how it works. But your client who just initiate the order is no longer waiting for the response. Later on you get the response on your email like order confirmed and everything, but here you are not waiting for the response and everything on your first place. So here we have like the channel types as well, like your point to point, which is your single receiver, one sender, one receiver, and PubSub model, as we already know, like multiple receivers. As I mentioned, the example of your order and payment. So as you can already understand, like what YouTube use point to point or PubSub, like you subscribe to any channel. So whenever someone or the owner of that channel publish any video, if you have subscribed and you get the notification, and everyone gets the notification whoever subscribed and turn on that bell notification like that. So now you can easily identify like which channel type YouTube use. Okay, now things to watch. Yeah, we have to, so we have to keep few things in mind while just working with your asynchronous pattern. It's like broker performance and scalability. Yeah, these are some of the bottlenecks, like your broker performance and the scalability. If you want to scale that, single point of failure, use HA setups. Yeah, there could be a single point of failure, then you must high availability setups must be there to handle the single point of failures. Then operational overhead, yeah, your installation, monitoring, maintenance, observability, these all could be your operational overhead because you have to manage all them. And next we have, yeah, and there are few challenges and best practices, I would say. Yeah, it's coming in the frame, but something is missing here. Yeah, now it's entirely coming in the frame. Cool. So if we talk about challenges, it's like latency and cascading failures. Yeah, because each network call uh, adds a latency, and we always want a low latency. As and cascading failures, I would say you have multiple services and they are calling like one to another, like your payment order and if one of the service fails, then your chain breaks. Okay. In data consistency across services, yeah, generally in a distributed systems, data takes time to be consistent in all of the places. It's called the eventual consistency usually happen inside your distributed system and the microservices. In the security, yeah, we all know we require the security. All the services should be protected, and we must use proper authentication and authorization for that between the services. And then we have the operational overhead, like for monitoring and all those, as we covered in the above slide. So now these there are some of the best practices, like use API gateway to manage requests. So the best practices are use API gateway to manage requests. It's like single points. It's like single entry point. You do not need to register anything, and your client do not need to worry about what would be the URL of each of the microservice and the port number and everything. Authentication authorization that you can implement here on the API gateway as well. I have just post on the API gateway as well. I have published one video on my channel, so you can go and check it out. You will get the link of that video in the description. And you can also implement the circuit breakers. Yeah, suppose, like as I mentioned, like services are failing, so instead of just making the request, we'll just trip that circuit or the path to that particular service. So we'll check once that service will up, only then we'll able to send the request. Meanwhile, we'll not send the request, we'll just break the circuit over there. Or if you want a dedicated video on how circuit breaker works, then drop a comment. I'll definitely make a video on that. Cool. And next we have adopt a service mesh. And yeah, it's like the in-depth, like how your services communicate with each other. Like what are the key aspects for that, I would say. It's like what path and how they find, like inside load balancer we have multiple instances, but how they actually communicate inside, like this is the abstraction, but how those works. If you want to know more detail, then drop a comment. Will create one, so I'll create one video on the service mesh as well. Okay, so adopt service mesh and don't go for security and all this, because it handles all the things there where we use the proxy and other things. So go event driven scalability. Yes, always go for event driven. So then you do not need to worry about your operational overheads. Just use the infrastructure of these all packages, and you will get rid of these of the like extra overheads or whatever was there. So that's all, or do I have missed anything here? I think that was for this video. Have I missed anything here? How? Let me quickly check. No, I think we are done with this. So that was all about this video. So if we conclude that, so there are two main ways, like synchronous and asynchronous. But again, we cannot say like synchronous is better or asynchronous. Generally, in the systems, we use the combination of both. That again depends on the requirement and the architecture what we are following. Okay, so that was for all about this video. If you found this video helpful or useful, or you think that you have learned something new, so hit a like and subscribe, and don't forget to share with your friends. I'll see you in the next video. Till then, keep learning, keep growing. Bye bye.